again. Welcome to Astronomy Toronto. I'm your host. My name is Randy Attwood, and I'm the president of the Toronto Centre of the Royal Astronomical Society of Canada. This is an organization of both amateur and professional astronomers who are interested in learning more about astronomy and watching the skies above Toronto. Astronomy Toronto is produced here at Rogers Cable 10 and is seen the first Thursday of every month at 8 o'clock. Well, in less than a year, Comet Halley will be gracing the skies over Toronto. Everyone's getting really geared up, buying telescopes, buying books on comets, and this show of Astronomy Toronto is devoted to looking at comets and especially Comet Halley. And really, what are we going to see when it comes by next year? My guest is Ian McGregor, who is at the McLaughlin Planetarium and is currently working on preparing information on Comet Halley for distribution to people around Toronto. And Ian, I'm very glad to have you with us today.
Very pleased to be with you, Randy.
Ian, my first question is, what is a comet?
Well, a comet can basically be described as a large snowball. And more or less with the winter conditions that we have around, if we have any snow and pick up some snow and make a snowball and throw it, that's basically what a snowball is, except a comet is rather, but it's much larger than that. People have not always known exactly what a comet is. Thousands of years ago, or even hundreds of years ago, people thought everything in the sky that they could see was a comet. Just not so good, a star. Mm-hmm. And they thought of hairy stars, broom stars, new stars, falling stars, shooting stars, wandering stars, all these different kinds of objects.
Basically something that really looked different in the sky, something they weren't used to seeing.
Exactly, and the hairy star is perhaps the first thing that comes along which is associated with a comet. Now actually, they could see a comet in the sky. They thought it was a hairy star. It was a star that had hair that was kind of flowing back from it, and hence its name. Now, when we come along and we think about our current models of comets, we have to perhaps go along and go to our next slide, I guess. We'll zip along here, I suppose.
Okay, let's look at our first slide.
And there we go. That's our hairy star.
Okay.
And an artist's depiction of what people thought it might be like. But, of course, today our ideas of comets are much different than that. We perhaps look at a comet as being something like our next picture. And this is, again, an artist's depiction of a comet. Basically, it's the large nucleus. The nucleus of a comet is somewhere between 5 and 10 kilometers in diameter. It's mostly made up of ice with a little bit of rock and dust thrown in. We're not completely sure of how comets are held together, but we know when a comet moves in towards the sun that the radiation from the sun starts to break up the ice particles. It starts to fall off. We see a few rocks that are sitting in there, and the comet's material falls behind the comet as it moves in towards the sun and produces the spectacular tails that we associate with them. Now, a comet's tail always points away from the sun. It's very important to realize. The sun has got this enormous source of energy and radiation, and particles are streaming out from it, and as the comet swings around the sun, this material falling off the comet produces a very long tail. Perhaps we look at an example of an artist's depiction of a comet from the last century. This is a comet from the year 1858. It was known as Donati's Comet, and we're seeing it over the city of London with London Bridge in the foreground and the very beautiful tail that we associate with the comet.
Well, let's say we're going to look back in the, say, last 10, 15 years. How many comets would we have been able to see from Toronto? Not that many, bright ones.
Not really that many. A bright comet perhaps comes on the average of every couple of years. The last century we had lots of nice comets, but in the past 15, 20 years we've not really had that many comets. A nice comet took place in 1967 when we had a comet known as Saiki. And Saiki was a very attractive comet, beautiful long tail. It was an example of what we call a sun grazer. There's a picture of Comet Saiki. It was named after the two Japanese astronomers that discovered that object. Then after Saiki in 1967, there was another nice comet in 1970 known as Comet Bennett. It was my first comet that I saw. It looked like almost like a dagger in the sky, an incredible sight to see this object sitting up there. Obviously not a star, but with a tail coming from it. The next comet that comes along that's perhaps spectacular was one that most people were rather disappointed with, and that was Comet Kohoutek, sort of the great disappointment for most observers in 1974. It had a tremendous build-up. We all remember what happened during the 9 rather pregnant months, shall we say, before the comet was supposed to come really close to the sun. It had been discovered 9 months before getting closest to the sun. Normally, comets are only discovered perhaps a month or so before they get closest to the sun. But this one, there was 9 months worth of anticipation, excitement, build-up of looking forward towards it. And the net result was that when it came along, it was a very big disappointment.
We have a slide of Comet Kohoutek. When you see it, oh, I think this is the next one. You might have seen Comet Kohoutek here. This is the very pretty one. This is the surprise comet of 1975.
Yeah, this is a very, very beautiful comet, Comet West. It was named after Richard West, who was the discoverer of it. It was suddenly just literally came into the sky, and it had been found just before Christmas, I think, of that 75. And in 1976, the second week or so, it became a very beautiful object in the morning sky just before sunrise, with a very, very beautiful tail to it.
It's interesting that you mention that. We should point out that if you discover a comet, and it's the first time that comet's ever been seen, you get it named after you. And there are some people who are spending a lot of their evenings, most of their evenings, trying to discover comets. And we have, there are two Canadians, two amateur astronomers, Rolf Meyer and Dave Levy, who both have discovered, Rolf has discovered four.
4 comets, his most recent one just last September. And then about, 6 weeks later, I guess, David Levy of the Kingston Center of the Royal Astronomical Society discovered a comet.
How difficult is that, Ian?
Well, it can take a long time. I think Rolf Meyer, when he makes his observations, he has got dozens and dozens of hours of observing before he finally discovers one of his objects. I think that David Levy has got something like 900 hours of observing before he finally discovered his very first comet. That's a lot of observing time, given cloudy skies and
hours of just sweeping up and down in the sky with a telescope.
Scanning all the stars, becoming very familiar with it. It's quite an effort.
Well, the comet that we're interested in is Comet Halley, and we should look at what Comet Halley is and who Halley was.
Halley was the second astronomer royal in Britain. He was he lived during the latter part of the 17th century, the early part of the 18th century, and he was very, very famous for a number of different things. His accomplishments were not only in astronomy, but in other areas of science. But in particular, he has this comet, which has been named after him. Now, we must realize that Halley did not discover his comet. He predicted the return of a comet in the year 1758. He had been observing the orbits of comets just after the time of Isaac Newton, and we were starting to understand why comets and how comets moved around the sun. And he noticed that 2 comets had very similar orbits, and they had been visible about 76 years apart. And he predicted in the very beginning of the 18th century that in the year 1758 there should be a comet visible in the sky in the same path. Now, Halley did not live to see the return of his comet. He died in 1742. But in December of 1758, this comet was observed. And because people have been anticipating and looking forward to see whether his prediction would be true, it has since been called Halley's Comet.
And there are several ways that people are pronouncing this comedy. And what is the proper way to pronounce the name of this
Well, some people
comet?
pronounce it as Halley, there's Hawley, and Halley, 3 different names. We have a feeling that Hawley was probably how Sir Edmund would have pronounced his surname. But it's important to realize that when he wrote his own name, this was a time when spelling of names was not that crucial, he actually spelled his own name 13 different ways in his various correspondence. We usually think of it today as Halley, Comet Halley. Halley is from the well-known rock and roll group of the 1950s, Bill Haley and the Comets.
All right, if we now know that Comet Halley is in an orbit, and the next question would have been, how far back do we have records of observations of this comet, which, as far as we know, has been circling every 76 years and visible every 76 years from Earth?
But once we understand the comet's orbit, and we know it comes back every 76 years, we can then go back through the historical records and see if we can find an object which fits the right observations and the right position in the sky. We can perhaps go along and consider the earliest records, which date back to the time of the early Chinese, perhaps the 4th or 5th century BC, and we see a Chinese manuscript which shows a depiction of a comet in it, or what the Chinese would have referred to as a broom star. If we come up to more recent times, we come up to the Bayeux Tapestry of the year 1066. This is depicting the William the Conqueror's invasion of England, and up in the top part of the tapestry is the comet, which is supposed to be an evil omen for the King of England at that time. We then go along to much more recent times, to 76 years until we get to the last apparition, the last appearance of the comet, which was in the year 1910. It was one of two bright comets that were visible in that particular year, and this is the front of the Globe and Mail newspaper, and it's reporting that the comet has been seen in the skies over Toronto. The comet itself was very beautiful in 1910. In fact, it was one of the most beautiful and good returns of the comet in the last couple of thousand years. The Earth was ideally placed for observing it, and the tail of the comet was very spectacular and very long. This slide is showing the nucleus of the comet with the long tail streaming behind it. It's important to realize that the nucleus is on the right of the picture is mostly made up of ice and dust, and the tail is streaming off to the left. The tail is mostly empty space. As the comet moves in towards the sun, the length of the tail changes, and we find that when the comet's far away, the tail is relatively short. As soon as the comet's closest to the sun, the tail gets very long, and then as the comet sweeps away from the sun again, the tail gradually disappears, and we just have the basic nucleus of the comet.
Comet Halley has got to be the most famous comet. Everyone has heard of Comet Halley, but I don't think many people have heard of Comet Encke or all the dozens and dozens of other comets that are known to astronomers.
There's hundreds of comets that are known.
Why is it so famous? Just because it's seen every 76 years?
Most often people think that the comet is famous because it's bright, and in fact it isn't. There are lots of comets that have been brighter than Comet Halley. Comet Halley is really famous because it comes back every 76 years, and that's very roughly a human lifetime. For example, the very famous writer Mark Twain was born in 1835 when the comet was around, and he died in 1910. Very roughly 76 years is a human lifetime. We have now recovered Comet Halley for this particular apparition that we are going to be experiencing over the next 14, 16 months.
You mean we've seen it already?
We have seen it. We've already observed it. It's been under observation by the largest telescopes on the Earth, and the comet was recovered in October of 1982 by the Mount Palomar 200-inch telescope, the largest telescope in the world, as far as the free world, I guess, is concerned.
Doesn't look like much in this photograph.
Not very impressive at all. We're not seeing any kind of a tail. It's just basically the nucleus that we're seeing. Now, as in our present skies this evening, if the sky happened to be clear and we go out and look up towards the stars, if we look towards the south, there's the very beautiful constellation of Orion the Hunter, very well known, one of the most beautiful star pictures in the sky. Mm-hmm. 3 bright stars of its belt, 2 stars marking its shoulders, 2 stars marking the kneecaps. And just about where the head of Orion is located is where Comet Halley is this month, or this winter season. As time passes, though, Comet Halley is going to swing across the sky and change its position quite noticeably. It's going to gradually go right across the sky from the winter constellations of Orion and Taurus, through Pisces, over into Capricornus and Aquarius, which are on the right-hand side of this diagram, and we actually know its path and where it's going to be.
So this is really the entire sky spread out like a map of the Earth, and
exactly.
You can see that the comet's going to go right from one end to the other.
It spends quite a bit of time in the vicinity of Orion. By next June, though, the comet is going to be in conjunction with the Sun, and we're not going to be able to see it. We're going to lose sight of it for about 2 months or so, and then it's going to move away from the Sun, and then we're going to go through a very exciting period of time, starting, say, maybe in the late summer, right through until the early part of 1986. The comet's going to get brighter and brighter as we go through the autumn. Probably the first reasonable observing window for looking at the comet will be sometime in the late autumn, and astronomers all over the world will be looking forward to observing it with the eye, unaided eye, looking through a telescope, not with a camera but with the eye. Second observing window is going to be in January. The comet should be fairly bright. It'll be in our western skies after sunset. In February of 1986, the comet will pass behind the Sun, and we'll lose sight of it. And tragically, for us, when the comet's going to be at its brightest, when the tail is the longest and most beautiful and most spectacular, the comet is going to be on the opposite side of the sun to us.
It's very difficult to get the idea of how it's going to be in the southern hemisphere or northern hemisphere. And Ian, you have a model here that, if you can get it up, we can see this model, and it depicts basically a three-dimensional view of the path of Halley's orbit, because everything isn't just like a flat tabletop. Halley's orbit does go above the Earth's orbit, so that it will somehow be above the sun. And if we could take a look at this, maybe you could explain this that you've made at the planetarium.
Okay, this is a very rough model. We are hoping at the planetarium to make some much better models of these, which might be available for sale later on in the year. This piece of cardboard represents the plane of the Earth's orbit. And on here I have drawn a circle which is representing the Earth's orbit. You probably cannot see the months on here, but the various months and the positions of the Earth are marked on it. The sun is, of course, at the center of the circle. This second template represents, right, there we go.
Okay.
So that's the Earth's orbit we have there.
Okay.
Now, we come along, and the second template that I have represents the orbit of the comet itself. The comet's orbit is not circular. It is actually part of a great ellipse. If we could extend it way out into space, the far end of the ellipse is beyond the orbit of Neptune. Now I come along with this model and just kind of insert these in here, like so. And this is basically telling us that the orbits of these two objects, the Earth's orbit and the comet's orbit, are at a bit of an angle to each other.
Mm-hmm.
Now it turns out that the comet, throughout November of '85 and December of '85, into January of '86, February of '86, and at this point,
Just turn it this way.
let's turn around a little bit here.
Okay.
Okay, that's good.
There.
And in February of '86, the comet is going to be closest to the sun. The sun would be represented right in this point. And in February, the comet will be closest to the sun. Its tail will be very spectacular. The tail will be pointing out basically like this. Unfortunately for us, the Earth is on the other side of the sun.
Mm-hmm.
The Earth is sitting way over here at that time, and that'll be a bit of a disappointment. So the Earth is here, the sun is here, and the comet is going to be right on the other side. Then as we go through past February and into March, the comet is going to move below the plane of the Earth's orbit, and it moves down to the bottom of what we have.
So you can see that the comet goes right underneath the cardboard, and that's really when it's going to be the best viewing for us.
Exactly.
All right, Ian, now you've talked about observing it from Earth. This is the first time that Comet Halley has been visible during the space age. Tell us about the spacecraft that are going to be observing it.
There's lots of exciting things happening as far as spacecraft are concerned. Last December, two Russian spacecraft were launched towards Comet Halley. There's in addition going to be two Japanese spacecraft and also one launched by the European Space Agency. And so altogether there's going to be an armada, if you like, of 5 spacecraft which are going to be heading towards the comet. And within about a 1-week period in March of 1986, these 5 spacecraft are all going to fly by Comet Halley and study it. Now of these 5 spacecraft, several of them are very, very close to are planned to head very, very close to the nucleus of the comet. In fact, some of them are basically going to be kamikaze missions. They will probably not survive. 1 or 2 of them are going sort of down the tail, if you like, and they should survive without too much trouble. The most interesting one of the spacecraft is the European Space Agency's spacecraft, which we have a slide of, and this is the spacecraft known as Giotto. Giotto will be flying very, very close to the nucleus. It is unlikely that that particular spacecraft is going to survive. It'll probably be wiped out.
Again, by all of the debris, the ice
By
and
all
rock.
the debris that's falling off the comet. We should perhaps realize that when the comet is closest to the sun, it's going to be losing something like 6 tons of material per second.
And again, do you have any idea how fast this material is traveling? It's like on the order of kilometers per second, right?
Oh yeah, this is it. It's probably dozens of kilometers. Maybe I think it's about 100 kilometers per second. I think
And if you
that the nucleus is traveling at.
And the trajectory of that spacecraft to catch up to Comet Halley, which is going so quickly. And I believe the time that it has a chance to make observations is very short too. Am I right?
Very, very, it's
So it's
very, very
basically
short. Comes
passing by the comet within a few minutes and all of the time spent is going to be within those few minutes to make observations.
Although we have three nations involved with observing the comet, the Japanese and the Soviet Union and of course the European nations, the United States is going to be very involved because of its tracking systems, and in fact this is going to be a great international effort. The first spacecraft that get there are going to have to make some detailed observations to figure out where the nucleus is. The Americans are planning to send up the space shuttle around the time that the comet is close, I think in March or April of 1986. And in fact, just in the past week, the crew for this particular space shuttle mission has been announced. They have a special camera and a special telescope that they will be using to observe it. In this picture, we have an artist's depiction of the comet in the background, the Earth, and we see part of the tail assembly of one of the space shuttles.
In this slide, Ian, is that going to be a graphic depiction of what the comet's going to look like?
I think probably there's been some artistic license taken. I don't expect that the comet's going to be anywhere near as spectacular as that.
In our next part here, we're going to be looking at exactly what it does look like. And the people I've talked to have mentioned that Comet Halley will race across the sky within a few minutes. And that isn't right, is it? It's not like a shooting star or a meteor. It's something that moves very little as each night passes, and that it rises and sets more than shoots across the sky. Could you explain that a little bit?
Certainly. We must realize that comets are very far from us in space. They are not objects in the Earth's atmosphere by any means, although thousands of years ago they thought they were in the atmosphere. We're probably, many listeners have probably seen meteors, shooting stars, falling stars in the sky. They're just little bits of dust about the size of your baby fingernail, and they burn up in a couple of seconds, several hundred kilometers above the Earth's surface. The closest that Comet Halley is going to get to us is approximately maybe 50 million kilometers away, and it's a very, very big object. From night to night, we would observe its motion relative to the background stars, but not perhaps just going out in the sky, look at it for an hour later you come out. You probably will not notice very much in the way of motion.
All right. Where do we have to look to see it? You think the first observations we'll be able to make with our naked eye will be, say, in November or just before Christmas in 1985?
Current predictions, there's lots of different opinions on this from professional astronomers. Some people think that in December the comet may reach naked eye visibility. Probably the best time to be looking will be the early part of '86. In January, the comet will be located in the western sky just shortly after sunset, and it'll probably be relatively bright at that time. So that's kind of the second window for observing it. The third observing window is going to be taking place in the middle of March. We see in the western sky after sunset in January. Early February, the comet will be lost to sight. It'll be too close to the sun to be seen and be lost in the sun's glare. And then in February, the comet will be in the early morning sky just before sunrise, and it'll be relatively bright. And then once we get into April, the comet will begin to be up in our northern sky, and it should be fairly bright. The tail, though, will be disappearing from us.
Here we have a few drawings of what it's going to look like in the sky. And could you tell us basically what these are showing us?
Okay, these diagrams are showing us we have the horizon, and then there is a vertical bar which is showing us the altitude of the comet above the horizon. If we're looking at our picture, for March, we're looking at the early morning sky, and the comet is over in the southeastern part and coming up. We then go along.
I believe this is March. Yeah, this is March, looking south. It's not going to get very high above the horizon. That's the whole problem.
No, this is it. It's much more of a southern hemisphere object. We should ideally be in South Africa or South America or Australia.
Well, maybe we can arrange that.
It'd be nice if we could do something like that. And then we go into the evening sky in April, and the comet is now moving away from us, and the tail is shrinking. If we're down in the southern hemisphere, say Australia or South America, the comet will be almost directly overhead. But unfortunately for Canadian observers, the comet's going to be relatively close to the horizon and somewhat difficult to observe.
Well, it's very easy to notice that Comet Halley fever has hit everyone around here, and especially the planetarium with phone calls.
Oh, yeah, there's been lots of phone calls coming in, lots of inquiries, And in fact, I'm sure, although I'm confident that the Earth is going to survive the return of Comet Halley, there's some question whether planetariums, astronomy educators, and observatories will survive it. We have visions of 150,000 school kids all writing essays on Comet Halley sometime between September and May of 1986.
Well, what are some of the activities that are planned here in Toronto?
Well, there are several things I think that are going to be happening. Certainly the Royal Astronomical Society of Canada is going to be planning probably some Halley star parties. We must realize they're either going to take place right after sunset, depending upon what observing window we're looking at, or in the very early morning. And I think it's been a long time since the RASC has held maybe a 5 o'clock in the morning star party.
But it's certainly going to be the best way for people in Toronto to have a chance to look at the comet, because we'll have all our large telescopes set out, and it'll be much better than the naked eye.
Exactly. We're going to be having special shows at the planetarium during the autumn and the autumn of this year and winter of 1986, talking about the comet. We are offering evening courses, 4-night evening courses on Comet Halley. We have a course starting in the middle of April, in fact, and they'll be describing the comet and what it's like as an object to observe.
Okay, Ian, again, in summary, when's the best time to see Comet Halley, and what's it going to look like in the last 30 seconds?
Okay, I think probably if you want to look for the comet, the best time to be looking either in January of 1986 over towards the western horizon after sunset, or probably late March, beginning of April over in the southeastern part of the sky, probably in the early evening. The comet's not going to be particularly bright, although there's lots of disagreement over that. It's not going to be a spectacular comet with the tail sweeping across the sky, but people should be interested in looking at it. And perhaps I just also mentioned you don't need a telescope.
You don't need a telescope.
Be quite happy with pair of binoculars or try the naked eye.
Great. Thanks very much, Ian McGregor, McLaughlin Planetarium. And I'd like to thank you for, again, watching Astronomy Toronto. If you have any certain things you'd like to see on Astronomy Toronto, get in touch with us at Astronomy Toronto, care of Rogers. My name is Randy Attwood. For Astronomy Toronto and all of us here, I'd like to say goodbye. Thank you for watching.